In this problem, we will study the population growth. The model we have is the rate, the growth rate is proportional to the population at the time t with initial condition at time equal to 0, the population is p naught. We will quickly solve this equation and we use that to solve our problem. First, we have derivative of p with respect to t equal to kp, and this is a separable equation. Multiply dt on the right and divide by p on the left. We have 1 over p dp equal to k dt. Integrate both sides. We will have ln of absolute values of p equal to kt plus c. And we raise both sides as a power of e. On the left hand side, we just have ln of absolute values of p. On the right hand side, we can write as e to the kt times e to the power of c. Now, since c is a constant, e to the power of c is also a constant. So we can write as on the left hand side, when we raise to power of p, but our power of e, we only have absolute values of p. Right. So we have absolute values of p, and that constant, let that constant be just another constant, c. So we will have constant c times e to the kt. Now, absolute values, if we remove it, we're going to have, if we remove the absolute values, we're going to write a plus or minus. And plus or minus a constant c, it is still a constant. So that we can just write this as a constant c e to the kt equal to p. Now we look at initial condition. This means when t equal to 0, population is equal to p naught. So we substitute p naught into p and c e to the k times 0. Now e to the 0 power is 1. We just have c is equal to p naught. C equal to p naught. So we will substitute in this equation. We have p equal to, instead of c, we're going to have p naught e to the kt. Right. If you memorize the formula, then we don't have to derive that every time. We can always just use that formula. We don't need to derive it. And of course, that also like the formula of continuous compound interest. All the same formulas also in chemistry, radioactive decay. But like I said, if you memorize a formula, we don't have to derive that every time. Right. Now we're going to use that formula to solve our problem. Let's summarize what we have here. So that is just derived of the formula. Now we summarize our situation. In the year of 1980, the population is equal to 1,200. In 2004, the population is 5,500. And in 2020, we don't know what is the population. Right, it will be easier if we let 1980 to be 0, in which case 2004 is going to be 24, and 2020 is 40 years after 1980. Right. Right. Now we solve the problem. First, I will look at this information. That is when t equal to 0 is 12,000. So pretty much 12,000 is the P naught. So we write the first point, t equal to 0, population is equal to 1,200, which is of course also the population at the time 0. With that we have P naught is 1,200, so we're going to have that. So that's the first information. The second information, let's do that in purple, is going to be this information. When t equal to 24, population equal to 5,500. Right. So we're going to substitute 5,500 in for P, and P naught we know it's 1,200. E to the K we know T is 24. Right. This is a simple exponential equation. We will divide 1,200 on both sides, and if we divide 1,200, 5,500 divided by 1,200, we have 55 over 12 equal e to the 24k. Take ln on both sides. We will have ln of 55 over 12 equal to ln of e 24k. Cancel ln and e. 24k is equal to ln of 55 over 12. So we will have k equal to ln of 55 over 12 divided by 24. Just going to leave it like that for now. Right. And finally, the last information, that is our last information. So when we have t equal to 40, population unknown. Right. Actually, I put the ln of 55 over 12 divided by 24 If we do that, we have 0.06343. 634. Right, good enough. Now that we know everything, the population is equal to initial population we know is 1200. The rate is 0.0634 and t equal to 40. If we do that, we have 1200 times e to the power of ln of 55 divided by 12 divided by 24 times 40. We have 15,175.75. We can round up to 15,176. So round up to 15,176. So that is the problem. Like that, the differential equation is pretty simple. Once again, if we memorize that formula, then we don't have to derive that every time. But once we have the formula, the rest is just algebra. We don't need calculus for that if we know the formula.